Welcome everyone. So I'll be going through the solution to question 334 from the list of sample exam P problems on the SOA website. So the question reads, a group of health insurance policyholders is composed of 60% men and 40% women. Of the male policyholders, 20% are smokers. Given that a policyholder from the group smokes, the probability that the policyholder is female is 20%. Calculate the percentage of female policyholders who are smokers. Alright, so let us start by writing down the information that we're given. So they're saying that 60% of the policyholders are men. I'm going to let that be M believing that a policyholder is a man. Probability of a male is 60%. Or rather I should say the probability that a policyholder is male is 60%. And I'm going to let M prime be woman. Probability that a policyholder is female is 40%. 40%. Alright? And they say of the male policyholders, 20% are smokers. So given that a person is a male, the probability that he smokes is 20%. That's 20%. Given that a policyholder from the group smokes, so given that a person from the group smokes, or given that a policyholder smokes, the probability that the policyholder is female, so the probability that policyholder is female is 20%. So now I need to calculate the percentage of female policyholders who are smokers. Calculate the percentage of female policyholders who are smokers. So this is a conditional probability. So this translates to, given that a person is female, what's the probability that person smokes? Alright, so in order for me to figure out what this thing is, I'm going to first figure out what S is. And the probability of S using the information that I'm given over here is equal to the probability that a person smokes given that they are male multiplied by the probability that they are male. So that is 0.20 multiplied by the probability that the person is a male, that's 0.60. So this is the probability of a person smoking and the probability of a person being male, and I need to add that to the probability that a person is female and smoke. So we can use this piece of information to get it. So the probability that a person is female given that the person smokes, that is 0.20, and I'm going to multiply that of course by the probability that the person smokes, probability of S. Alright, I'm going to solve for S. So I need to bring going to bring this over to the left hand side, so I'm going to be left over here with the probability of S minus the probability, not the probability, but rather I should say I should rather have here 0.20 probability of S, which is equal to 0.2 multiplied by 0.6, and that is 0.12. So over here I have 0.80. Come on, pin, don't give me any problem now. Probability of S is equal to 0.12. Solving for S, I'm going to end up with 0.15. Alright, so that's the probability of S. So now that I have the probability of S, I'm going to go ahead and use the law of total probability, similar to what I did up here, to actually get what I was asked to find here. Alright, so the probability of S, which is 0.15, that is equal to a person smoking and being female plus the probability of a person smoking and being male. So that is the probability of S given M prime multiplied by the probability of M prime plus the probability of S given M multiplied by the probability of M. Alright, and remember, this is what we were asked to compute. We were asked to find that value, find out what that probability is. So we have 0.15, and this is equal to probability of S given M prime. Don't know what that is just yet. And the probability of M prime is 0.40, plus the probability of S given M. Let me go back up here a little. The probability of S given M, that is 0.20. So we have here 0.20. And what's the probability of M? The probability of M, that is 0.60. Alright, so remember that probability of, remember that 0.2 multiplied by 0.6, that is 0.12. That's 0.12, yeah. That is 0.12. Let me check that again. 0.2 multiplied by 0.6. Right, it's 0.12. So we have right here 0.12. Now I'm going to bring it over to the left hand side. So we have 0.15 minus 0.12 is equal to the probability of S given M prime multiplied by 0.40. So 0.15 minus 0.12, that is 0.03. So we have 0.03 here is equal to probability of S given M prime. Multiplied by 0.40. Solving for S given M, I'm going to divide both sides by 0.40. Alright, and finally, this will give me probability of S given M prime. That works out to give me 0.075, which is the same as 7.5%. 7.5. The lag, but I don't understand why my pen is lagging so. Question is true, so we're fine. So the answer is 7.5%, which corresponds to A. So our answer is A. Now, if you have any questions or any suggestions, I would very much appreciate hearing them. Thank you for watching. See you in the next